Okay, so here's our thing. If I ask you to take d over dx of sine of x, we all know that's easily that's easily cosine of x. Easy peasy. But we have a new list of inverse functions. And if you guys remember what inverse functions do, they take the ratio of the sides and give you back the angle. So just as a reminder, if I say sine of theta is equal to opposite over hypotenuse, we could take the inverse of both sides. And that gives us beta equals a sine inverse. Okay, you guys remember that's the tool. Inverses cancel out whatever function you're trying to take the value of. So the signs cancel out, leaving you just theta. That's what inverses do. So why do we have to learn inverses? Well, we learn the inverses of everything else. The inverse of addition is subtraction, inverse of multiplication is division, and vice versa. So we learn those derivatives. We learn the inverse of squares are square roots. We learn those derivatives. So this is another tool that we need. So the derivative of sine inverse, okay, of x is equal to 1 over the square root of 1 minus x squared. This can also be written as d over dx of arc sine x. Same answer. Okay, that's just the straight definition. Okay, and really, you just have to memorize them. So I'm going to throw a thing about chain rule in a little bit. And if you want to look for a nicer version, this is posted on the website. But cosine inverse of x is equal to, what did I tell you about taking derivatives of anything with a co? Right? It's always going to be bad. You're always going to end up with a negative sign. Square root of 1 minus x squared. And these two look very similar to each other, right? It's like its evil twin. Okay, so it's 1 minus x squared. And we might say, where the hell did that 1 minus x squared come from? And I'll try to demonstrate that today. And then 10 inverse is, this one's the cleanest one. It's going to be 1 plus x squared. Super clean. Super clean. No square root.
Mr. Co?
Yes.
Mr. Co?
Yep.
How do all of these equal that?
It's a straight memorization right now.
Yeah.
I will show you the proof behind it after I show you all of them. Okay. So.
Okay, thank you.
And then I'll work it out. But these are our straight definitions. Just like when you memorize the derivative of sine is cosine, this is what the derivative of inverse is. Straight memorization right now. And I want to make sure you see the pattern. It looks like we're memorizing a lot, but you're really only memorizing 3. Okay?
Mr. Ko, just for clarification, the inverse of sine or inverse of cosine or inverse of tan is the same thing as arc sine, arc cosine, and arc
yes. So if I say d over dx of arc cosine, that is the same derivative. The derivative of arc tan x, same thing. Okay, so they're interchangeable for us. So we did sine, cosine, and tangent. Here's something we want to say about arc cotangent. Sorry, arc, one more time. Yeah, arc cotangent. The derivative, real quick, of cotangent inverse of x is equal to, remember, whenever you take the derivative of a co, you end up with crap. Looks very similar. All right. And then let's go do our reciprocal identities. So d over dx of, let's do secant first, because that's not negative. Secant inverse is equal to 1 over, now remember, when you end up with crap, you should end up with crap. So we're going to stick our little square root in front, x squared minus 1. It's the flipped version of that, so be aware. They look similar, but it's the flip version of it. And what do you think the derivative of the cosecant is going to be? The pattern seems like it's there. Okay. So once you guys are done copying it, I'll go ahead and talk a little bit over it. It's just like when you guys memorize sine, cosine, and tangent, you just had to remember derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. And then you use those as a basis to remember all the other ones, cotangent, secant, and cosecant, hopefully. Now, very similar in this way for derivative of sine, okay? It's just 1 over, just take it as fact, 1 over square root of 1 minus x squared. The derivative of inverse cosine cosine inverse is negative, same thing as sine. Tangent and cotangent, 1 over 1 plus x squared, no square root. Cotangent is negative though, because cos always give you that bad taste in your mouth. Okay? Negative. It's like eating garlic. It's like it's in your blood. Okay, and then the derivative of secant inverse is 1 over absolute value. Don't forget the absolute value, and the square root of x squared minus 1. Okay. Let me do one problem for you. If I give you d over dx of, let's do sine inverse of 3x. Okay, so go ahead and look at your identity, and you could call this is like your new x. Okay, oftentimes we will use the word, many times when you look at these identities up online, they'll use the letter u instead, so we don't get these confused. Okay, and so we go ahead and follow the rule. We copy it exactly, 1 over the square root of 1 minus x, quote unquote x, which is now 3x squared. And then, so please remember, chain rule applies to everything. This is the derivative of sine inverse. That's this right here. But don't forget chain rule. The derivative of 3x is just 3. So we have to apply chain rule to everything. If you look at other ways of writing this same exact derivative, people will write it using this instead of u, and they'll say it's 1 over square root of 1 minus u squared times u prime. Just to remind you, chain rule. But it's really no different than what we went through. Okay, except we have to actively remember chain rule. I'm gonna do the same problem. D over dx sine inverse of cosine. Okay, just throw something weird out there. Copy it exactly what the identity says. 1 minus cosine squared x. And then we multiply this by the derivative of cosine, which is negative sine of x.
Do we have to simplify any of these anymore or no?
You should be able to. So if I write, if you guys remember the Pythagorean, a squared plus b squared equals to c squared, which is also sine squared plus cosine squared is equal to 1. If I rewrite this as s squared equals to 1 minus cosine squared, so you can rewrite it as 1 over square root of sine squared times negative sine of x. The square root of sine is 1 over sine times sine. They cancel out, equals to negative 1. Okay, so that's really how you use it. Honestly, that's how you use it. If I do it one more time, let's do it with natural log. Sine inverse of e to the, nope, let's do the natural log. ln of x. Okay, that's going to be 1 over the square root of 1 minus natural log squared times the derivative of natural log is 1 over x. Okay. So hopefully you guys find it fairly simple. If I go ahead and do d over dx, let's do tangent inverse of x squared. Just copy the rule. Go ahead and copy the rule. Let's see if you guys can do it. So hopefully you wrote, let's take a look. Tangent was 1 plus x squared. So 1 plus x squared squared. Don't forget chain rule. 2x. Hopefully you guys get the pattern. Not impossibly hard, just 3 more things to memorize. Now, so how did they come up with this rule? Well, I mean, in the quest to solve everything, right? So let's go ahead and prove why this is true. So y is d over dx. Here's our proof. Is y is d over dx of sine inverse of x equal to 1 over the square root of 1 minus x squared. Okay, that's our question. So in order to do this, there's a couple different ways, but why don't we use the rule we just used? So I'm going to write this on the side. I want to say x is equal to, call this g of y, okay? Which is equal to sine of y. Okay, how did I get this? This is our inverse function. Okay, if I said y is equal to f of x, which equals to arc sine of x, if I take the sine of both sides, you get this guy here. Or if I do sine inverse to both sides, right? Does that y equal to this guy here? So just keep this in mind. That's going to be our trick later. So y is equal to sine of y, okay, which is like our inverse idea. Okay, so if you remember our rules for derivative of inverse functions, okay, so if I'm asking for the derivative of it, remember we wrote this idea before, f inverse of x, remember that? And we said it's 1 over f prime of f inverse of x. That's essentially what we wrote.
So pretty much it's 1 over f prime of y.
Yeah, that's the
Okay.
idea, right? Y from like our, yeah, this is our y. But it's the y in the inverse version. So I'm going to rewrite this as 1 over, we're going to call that g of y, but the derivative of g, which is us writing 1 over pretty much sine of y. And are we going to take the derivative of that? Okay, that's this, just copying it over. The derivative of sine is cosine. And we're going to say this is, do you guys remember the Pythagorean identity we just did? Sine squared plus cosine squared equals to 1. So cosine is equal to the square root of 1 minus sine. So it's going to be 1 over the square root of 1 minus sine of y.
Wouldn't it be sine squared? Or
Yeah,
yeah.
sine squared. Look here. Sine of y is just x in our tipsy-topsy world. So it's 1 over square root of 1 minus x squared. So that's in our weird way of saying it. So we actually use our inverse rule, derivative of inverse functions. So we just said, hey, the derivative of our inverse function of this weird sine inverse rule, or you can say arc sine, is just really the derivative of the original function, sine, at the y value, but we're really our original x value in our regular, not inverse world. Okay. So it's a little bit weird, right? So I think the hardest part to get over is this step here, because the derivative of f is really the inverse. What is the inverse function in the regular world? It's just regular sine. So we plug in x, we plug in the y version, because y is really the x in the original world.
Mr. Coe,
Yep.
Jacob Posner says he got kicked out. I think he's in the waiting room.
Oh shoot, there's like 2 people there. Oops. Sorry, if I don't scroll to the top of my participants, I don't see them. There's someone else waiting out there. Oh, that's what all those emails were about. I was getting a lot of ding, 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 ding. Let us back in. Thank you for letting me know. Oh, he's still like joining. Oh, maybe he has internet problems. He might have to quit and then restart his Zoom. Okay, so you can look up other proofs online, and there's actually a lot out there. There's another way of doing this proof by just writing the inverse. But I don't think we have time for that. Hi, Lena. Sorry about that. Left you out there in the cold. Okay. So the next one we want to talk about is, actually, you know what? Let's just do one more example. Just one more example. Just working out the problem. So let's take d over dx of, let's do cotangent inverse, sorry, of, let's do x squared plus sine of x. Okay. Go ahead and write that derivative. You can look at your cheat sheet, that's fine. And if you want to look at the proofs one more time, I posted up a link in the homework section and you can take a look. Okay. 1 over negative, and then we're going to say it's going to be 1 plus x squared plus sine x squared. That's the rule. And then chain rule that, 2x plus cosine. Okay. Okay. Uh-oh. Okay. I'm okay. I'm still here. I got kicked out. Now, today's real main point here is we're going to do something called implicit differentiation. And this is a fancy word of taking the derivative when it's not x? What if it's anything else in the world? How will we take that derivative? Now, let me go ahead and go through an easy derivative. The derivative of x squared plus 2x plus 1 is a derivative because of a plus sign. Then individually, it's d over dx of x squared plus d over dx of 2x plus d over dx of 1. And you can look at this a lot of different ways, but what's the derivative of x squared? Okay, we can do the power rule first and chain rule it. The derivative of the outside is 2, leave the inside alone, and then we take the derivative of the inside. And the derivative of the inside is 1. Derivative of x is just 1. The derivative of 2x is 2 on the outside, and the derivative of x leaves us 1. And the derivative of any constant is 0. Okay, so take a look at how I did that one more time. When I take a derivative of a plus sign, I take a derivative of them individually. Now, the most tricky one is actually the first one, x squared, because when I'm taking the derivative of x squared, I can't take the derivative of x yet. It's inside a shell. So we do chain rule to it. Derivative of the outside first, again, leave the inside alone, then times the derivative of the inside. And you notice dx over dx cancel out. Now, what if I change this problem and I use the wrong variable, d over dx of y squared plus 2y plus 1? How does this change my problem? Well, let's do it. The derivative of y squared is going to be first the derivative of the outside, please, which is 2, leave the inside alone, times the derivative of the inside, plus, let's keep on going. The derivative of 2y is just 2 in the front, dy over dx. And what is the derivative of 1? That hasn't changed. That's going to be 0. And it turns out this is actually our derivative now. Because the dy over dx do not cancel out. And that's what implicit differentiation is. That's it. If it doesn't cancel out, leave it alone. Good job, guys. Well done. What's the derivative? With respect to x of sine of y. Let's try this. Okay. Do we go after the y first or the sine first? We go after what's on the outside. If you want, let's draw our little rings of power, our parentheses. If we take the derivative of the outside first, so that's going to be cosine, leave the inside alone. We take the derivative next to the inside, it's dy over dx. I cannot cancel out the dy and dx, so we leave it. That's implicit. There we go. Let's do another one. Here is something a little different, dt. To respect to time, I'm going to take a derivative with respect to time of this popular equation, x squared plus y squared. Okay. So I want you guys to see if you guys can do this yourself. See if you can do it. If you can't, make some guesses, but it should only take you a couple of seconds. What's the derivative of x squared? We just did it up there. Take a look. But instead of writing x, we're going to write t for dt. Right. Hopefully you guys are on your way. So derivative of the outside is 2 first. Leave the inside alone. Then derivative of the inside is dx over dt. Plus the derivative of the outside is a squared power rule. Leave the inside alone. Then derivative of the inside is dy over dt. The whole idea here is that since it's not x dx over dx, it doesn't go away. If I had written this as the derivative, so here's a side note, okay, different one, d over dx of the same problem, okay, same problem. This would be 2x dx over dx, because the derivative of x with respect to x, plus 2y dy over dx, derivative of y with respect to x, they don't cancel out. So you can see the difference because the x's cancel out, but the y's don't. Okay, hanging in there, guys?
So if they don't cancel out, what does that mean?
You leave it. The point is, that's fine.
Oh, so that's the complete answer.
Yeah.
Okay.
They're going to have us do some more stuff to it. But right now, this is just the learning goal to realize it's okay. And if it doesn't match, doesn't cancel out. Again, we've been doing this like from day one. The derivative of 2x, we just said, was 2 dx over dx. But we don't write this, do we? Because don't we just call that 1? To save time, 100% to save time. But algebraically, this kind of makes sense, right? Dx over dx cancels out. What's the derivative of x? 1, right? If we say, what is the slope of the graph of x? The slope is, here's the graph of x. The slope is rise over run, rise over run, rise over run. That's 1. Practically works out that way too. Or dx over dx is equal to 1. And this guy who came up with this is crazy, I'm telling you. All right, so how do we apply this? Okay, so let's go ahead and take an example from your Excel today. If I say x equals to 2y squared minus 46, this is just an example I'm just pulling off. And here's the question they're asking for. They're asking for what is y prime? Now, let me help you redefine y prime. Y prime is the derivative of y. It's the derivative of y. Okay, that's what it is. It's a derivative of y. So I don't have the derivative of y here, but how could I get the derivative of y? I would have to take the derivative. So the goal is for you guys to realize if I'm looking for y prime, I need to take this derivative because I see a y. You guys all see the y? And I'm going to take a derivative of that y eventually. So let's go ahead and take a derivative of the whole problem. D over dx of x equals to d over dx of the whole problem 2y squared minus 46. So if I do one thing on one side, I'm going to do it to both sides. Okay, so let me ask you guys, on the left side here, what is the derivative of x? Or what is dx over dx? Doesn't
1.
that? 1, yeah, perfect. Right, that's what we always thought. The derivative of x with respect to x is 1, or dx over dx is 1. Now the next part is going to be a little tricky, but let's go and take that derivative. Remember, it's a minus sign, so we do them separately. Do them separately, no problem. That's going to be 4y dy over dx minus d over dx of 46, which is, we know it's a constant, so see you later, Hal. We're left with 1 is equal to 4y dy over dx. Now, remember, they asked us to solve for y prime, dy over dx. Hey, don't we have dy over dx here? So get your roommate to move out, because my girlfriend's moving in. Get out 1 over 4y equals to dy over dx. Okay. I'm going to do the same problem with a different notation now, okay? Which is an easier notation. Okay. It doesn't put this guy to shame, what we wrote, but it'll be easier to look at. Here we go. Same problem. X is equal to 2y squared minus 46. Okay, we're going to do the same problem, except I'm just going to ask you to just take the derivative. What is the derivative of both sides? What's the derivative? So in your head, what's the derivative of x? 1. What's the derivative of 2y squared? Power rule, 4y. What's the derivative of y? Y prime. Okay. We wrote this exact same thing right here, except instead of writing dy dx, we just write y prime. It's just a different notation. And we solve for y prime. Same answer. All right, so the idea here, and this is the hard part about calculus. The calculus problems always start off with some type of equation here, but they give you y prime. Y prime doesn't have anything to do with what they gave you. You have to come up with that yourself. And that is the part that's a little bit tricky. Like, what do I do to get to what they want? And let's do another problem here. So if I say x is equal to negative 2y squared plus 5y plus 1, I'm going to do this in both ways. You make a choice. You can say dy over dx. Or you can say y prime. Both 100% correct. Okay, both are 100% correct. So let's do the dy dx away. D over dx to both sides. X and negative 2y squared plus 5y plus 1. Okay, on the right side, we're just going to take the derivative of both sides. I've seen people do this notation. That's not a 1 in the exponent. That's like a derivative, like a dash, right? Or prime. Sorry, it's called a prime. Prime to both sides. So the derivative over here is dx over dx. And it naturally looks like that's 1, right? Do our derivative on the inside, so it'll be negative 4y, chain rule dy over dx, plus 5 dy over dx, plus 0, because the derivative of a constant is 0. To rewrite this nicely is negative 4y dy over dx, plus 5 dy over dx. Now, the goal of this problem is to say solve for y prime. Okay, and I don't have y prime here. Now, this is why this is a little tricky. If I want to solve for dy dx, look, do you see how we have dy dx here? They're two different terms. So we have to factor it out now. Dy over dx factored out negative 4y plus 5. We factor out what's in common because we want those to be alone. That's what we're solving for. Then we divide it over. 1 over negative 4y plus 5 equals to dy over dx, which is y prime. Now to work with the easier notation, not taking away from us writing d over dx, is the derivative of x is 1. The derivative of, sorry, that's a squared here. Negative 2y squared is negative 4y, y prime, plus 5y prime, plus 0. We are going to do the exact same step of factoring out the y prime. And we're going to divide that over. Okay, to illustrate both different ways of doing this. Now, why do we do this? Like, the main reason why is that you can't always solve for y. So let's give you an example. If I say x is, sorry, let's do an easy one. Y is equal to x squared. Okay, let's say this. If I solve for y prime, that's going to be 2x. Easy, right? We know that. But what if I gave you it in a little different way? What if I wrote this as square root of y is equal to x? Let's take the derivative and see if we get the same answer. Look for y prime. Okay, let's leave it alone and see what happens. The derivative here would be 1 over 2 square root of y prime is equal to 1. Yeah, that's good, right? Straight memorization. Solving for y prime is equal to 2 square root of y. But take a look. Isn't square root of y just x? Y prime is still 2x. Okay. So if I gave you this problem here, you could have rewrote it. And you said, you know what? If I square both sides, isn't y equal to x squared? And then we have this super easy problem to do. Yeah, solve for y. If you can solve for y, solve for y. Great, do it. I'm not holding you back. But look at our last problem that we did up here. Can you solve for y when it's y squared plus y? You can't. In this problem here, you could have solved for y. You could have said, this is x plus 46 divided by 2 square root. You could have done that. So the issue is sometimes you can rewrite it and sometimes you can't. And when you can't, take it as it is. Definitely, if I rewrote this problem, this would have been so much easier to do. Right? Less ugly. But if not, that's what we do. Okay. Now we're going to do one more derivative here. We're going to say x equals the sine of y. Okay. Last one. Okay, last one. Okay, let's go take the derivative. So d over dx. Oh no, that's the prime version. Let's do prime version. Okay. So the derivative, so find y prime. Thumbs up. All right. Oh darn it. I didn't have my video on. You guys, I've been waving to no one. Okay. So find y prime. Okay, let's take the derivative. The derivative of x is just 1. The derivative of sine is cosine of y prime. All right, let's go with that. Yeah. And then let's go ahead and solve for y prime. Y prime is equal to 1 over cosine. Nothing wrong with this. Okay. Now, let's see. Okay, I want to give you guys a little identity here. You guys agree with me? Sine of y squared plus cosine of cosine squared of y is equal to 1. You guys all agree with me there? Cosine squared of y is equal to 1 minus sine squared y. Still hanging in there? I want to get rid of the square. So cosine of y is equal to the square root of 1 minus sine squared y. Everyone's still coming along? Okay. And I'm going to rewrite this as y prime is equal to 1 over 1 minus sine in squared of y, all underneath the square root. That looks ugly. Everyone's still hanging in there? Yeah? Now, what did we say sine of y equal to? Equal to x 1 over square root of 1 minus x squared, which is the same as the derivative of sine inverse. Because y, if I take the inverse of both sides, sine inverse of x equals to y. That's our proof, baby. Sorry, you guys are staring at this. And this is where we started off today on the idea of the derivative of inverse functions.
Andrew put a question in the chat, sorry.
Oh, sorry. What if x and y were next to each other? Oh, that means you don't like yourself and we have to do product rule. Okay. So if you guys look at what I just did here, it really is, this here is like the idea of inverse, right? We take the inverse and take the derivative. So if I had just jumped here, we would have actually got to our answer right away. Straight identities. Okay. So that's how they come up with this derivative. So good question. Let me do negative 5y squared equals to 2x squared y minus 12. Now we're looking for y prime. Sorry, Andrew. That next line, -5xy
No,
squared.
that because I messed up and I meant
So
to say
swap
that
it?
instead of yeah.
Okay,
No,
let me
I
swap
meant
it.
to say I added x between the -5 and y. I just forgot it.
Oh, got it. Okay, right in the
Yeah.
beginning. So you really don't like yourself. Got it. So whenever you have x and y, this is really an f times g. It's actually two different functions multiplying. So you have to use product rule. So let's take the -5 and the y and the x separately. So -5 parentheses 1, derivative of x is 1, y squared plus derivative of the back, which is 2y, y prime, leave x alone. Okay, so that's our derivative, and that's us leaving it alone. So when you take the derivative of y squared, it's 2y, y prime, because of chain rule. And over here, we need a product rule. Derivative of the front. The derivative of x is 1, so I don't need to write that. Leave the back alone. Derivative of the back, we're just using y prime, right? Leave the front alone. And then plus 0. Now this problem looks really messy, but let's go ahead and multiply the -5 out. Multiply the 2 out. And if we're solving for y prime, we need to get y prime on one side. So this is straight algebra 2 here. Okay, we need y prime on one side, and we'll factor and flush everyone out. So I want to move everything to the right side because I don't want that -10. -5y squared minus 4xy. Move this guy over. Move this guy over. We'll say it's going to be 10y, y prime x plus 2y prime x squared. Take a look, we both have a y prime. We factor it out like our last problem. We factor it out. So y prime left over 10yx plus 2x squared, and then we flush everything over. -5y squared minus 4xy over, copying everything that we flushed over. This is more writing than actual like calculus. The only calculus step you have is that first step where you take the derivative. Everything else is algebra 2. So Andrew, I'm going to have you walk us through the problem. What happened from this step to this step? Which special
So-
rule did I need?
Was that like chain rule? Is it called?
Not chain rule.
Not
Starts
cha-
with a P.
I don't know like the names, but I know how to do them. Problem. Product rule.
Thank you. Product. Good job. I'm glad you memorized that. So product rule, because when things are multiplying, it's product rule. Okay? Derivative of the front, leave the back alone. Derivative of the back, leave the front alone. And derivative of y is y prime. Cool. And from this step to this step, which rule do we use again?
Product rule.
Thank you. Derivative of the front is 2x, leave the back alone. Derivative of the back is y prime, leave the front alone. Okay? Multiply the 2 out. Multiply the -5 out, we end up with this ugly mess here. Now, if they're solving for y prime, right, y prime's not alone, so let's get it alone. Move the y primes to one side, move non-y primes out. And now we factor out the y prime, and then we flush everyone else over. And this is equal to y prime.
Okay, thank you.
So, okay, that's pretty much it for the day. Hopefully you enjoy that. The little, like turn in our story at the end. The butler did it. Okay. If you have any questions, go ahead and ask me. You can email me if